Well, hello everyone. Does it look like we're good on IT? Ariel? Okay, great.
Yeah,
I'm hosting this time, and I have no knowledge of the inner workings of YouTube Live. So, if there are technical difficulties, I will try to notice them. But welcome everyone to Dev Empathy Book Club. We're here to inspire each other to become better developers and better people by building our empathy skills. Today we are jumping right into The Mythical Man-Month by Frederick Brooks. We got this lovely shot that is probably not that viewable. Thank you, Ariel. That's a better one. And we're, the older version. We're reading from the first chapter through the end of chapter 8. So that should be the final chapter, is Calling the Shot. And I just wanted to start off with some of the first thoughts on this book. I think it is really fascinating to see so many foundational ideas of what we consider to be good programming and how we interact with one another expressed in this book, whether it's the idea that onboarding is tough and that throwing a bunch of people on a project doesn't make it get faster, or the idea that maybe programmers get experience in interesting ways and wear their battle scars on their sleeves, a bit, to the choice of language affecting productivity, something that many of us as Rubyists really connected with. So I just wanted to start out with what are people's first impressions? Justin, if you want to start.
Yeah, so my first impressions reading this book, I had read a little bit of it years and years ago. Like I don't think finished the whole thing, but I had skimmed a lot of it. And I remember at the time being like, yeah, this is good, all this, great. And it's funny now going back and reading it and being like, oh, so many small quotes, like a game of telephone, have come from this book and been inherited around forever. But as far as like first impressions or takeaways are concerned, like, oh my God, the amount of like gendered language in this got to me. Like sometimes that doesn't get to me. And sometimes I'm like, oh, you know what? They should be better at or more equitable about changing up the gender terms, or for me, just genderless terms. Like they work so well in books. It's so fluid, but every single sentence was like he, and then he, and then he. It sort of like berate me at a certain point. I was like, oh, I'm pretty sure without fail, every single example is him and he in the entire book. And it really, I think, dated the book a little bit. It definitely put it back in its place, but also, it almost became exhausting. I actually have a weird habit of sometimes I will actually correct books and I'll write they, but I was like, I can't. I'll be just marking up every page. And I just had to like kind of put that away. So it's an interesting spot where it like shows its age, but it shows like, oh, there are some really good things here. And yeah, it's all over the place.
Yeah, it's funny because look, this was a book that was written I think in 1975 maybe. It's it's an old book, and part that's definitely part of where that's coming from. Like it's hard to remember, but I'm pretty sure when I was like really young, it was still fairly common. It was falling out of fashion, but it was still fairly common to see the masculine used as the equivalent of what we use they for today. So that jumped out at me less than the fact that it was constantly men. I could excuse the he, but when there, you see so much talking about the man who was doing this, the man who's doing that. I think that's where you really sort of see like really imagining programming to be very much a man's world. And it's actually just interesting to me from a historical perspective because this is a time not too long after all programmers were basically women, right at the beginning, for some who might not be familiar, once upon a time, the role of I think it was actually called programmer, which basically meant that you were doing all the wiring on like ENIAC kind of computers. That was all done by women, and at some point it was taken over by men, and we're still trying to recover from that today. But it's what's interesting to me is that like very, very clearly this person is imagining men, and it's not that far after when that transition happened. So you can see how much the pendulum swung in the other direction. It's a little bit scary. Yeah. I don't have a lot of intelligent things to say about it. But it was extremely striking, and it kind of helped me appreciate why someone who is coming in and keeps reading man and thinks like that doesn't apply to me, maybe regardless of how many man months, or is it mythical, is it not mythical, right? But if it's a man month and I'm not a man, then this I don't have a part in this.
Yeah, I think it is interesting to think of this in historical perspective, because it affects not just the cultural times, but the system that this person was designing. He was working for IBM on a series of systems that included both mass manufactured and custom ones. So one of the funnier custom ones was, if you've seen Hidden Figures, the IBM mainframe that that IBM provided to NASA is among the systems that, if I'm reading Wikipedia correctly, that Fred Brooks was designing the operating system for. And it varied in size. These systems varied in size from something massive mainframe to the smaller mainframe of it's the size of your average man-size safe, but with a memory. I can't remember. I'm going to struggle here because I interpreted 32 kilobytes of memory to be RAM, but I'm guessing it could have been disk space too. So yeah, like that was the scale of this operating system. It was literally something that you could walk up to and walk into, and it was that far back.
Yeah, I think I mean, you looked into this more than I did, but I don't know at what point even the idea of a hard disk started to exist. My understanding was that you just fed in the OS along with the rest of the program.
Oh, that's probably correct. Yeah. I have not looked into enough of this. I just saw 32 kilobytes, and I was like, that is tiny. I have data files that are, I don't know, orders and orders and orders of magnitudes larger than that. Yeah, I think Ariel, you did have some thoughts on why things have changed and why it feels so dated.
Yeah, I mean, it's interesting because some of the ideas in the book are at least a few decades later, which in the grand scheme of things maybe is not a lot of time, but a lot has happened. So some of the ideas definitely feel much more timeless, and some of them really you get the impression that this was a thing for that time, and times have changed in fundamental ways that have dated it. And it's very easy to kind of go through and be like, okay, this idea is dated and this is not relevant anymore and whatever. But to me, what's interesting is thinking about not just is it dated, but why is it dated? So as an example, since we're coming off of the design of everyday things, which is actually still on my desk right now, so that's how fresh it is in my mind. Haven't even gotten to put it back on the shelf. So one of the ideas of that book was the best way to avoid human error is to not make a human responsible for something. So whether that's remembering a bit of information or having to do an extra thing, anything that you can take away that humans don't have to do, that will at some point probably save you from a quote unquote human error. So I guess in my edition, the 20th anniversary edition, page 56, the author criticized a piece of his operating system, or the operating system that he designed, I guess, for using 26 entire bytes on handling the last day of a year in a case where it has an extra day, right? A leap year where there are 366 days. So we wasted 26 bytes of ROS. So I did a quick calculation, and that's actually 0.3% of the space you had to work with in the most minimal version of the physical hardware that's implementing this OS. So if you're talking about a third of a percent of your entire machine is taken up by this bit of code, at which he said, the operator should have to account for that. I look at that, I shudder, like, no, the operator is not going to remember, once in 4 years to do this random, little accounting thing, and even how you account for it, like, you're introducing so many opportunities for errors. But when you're talking about a third of a percent, right, 1/300th of your entire system, that you do that 299 more times, you don't even have space for the operating system, let alone the actual programs that you're running. So the trade-offs that we're making are very, very different today, and that's given us the leeway to think a lot more about the users of our system, design principles, things like that. The other thing that I talk about, and I think we're going to talk about it a little bit more later, is the idea of the surgical team, which is an interesting, concept, basically, that you have a team with a lot of different functions, and rather than having, each person be responsible for a whole list of responsibilities, you divide up the responsibilities amongst the team, and then you let, like, the one or two good, best people on the team just focus on programming. We actually, I think, do that today also. Just instead of having whole teams around programmers, we have a whole slew of hardware and software advances that have stood in the place of those things. So it's not that the idea is now irrelevant. It's just that we've chosen a different implementation, right? We've taken the concept and the interface, but we've switched out the implementation. So instead of having people who are dedicated to all these roles, we now have certain functions that are just handed over to certain software solutions, right? Whether it's instant compilers, automated testing, things like that.
Yeah, I think that's a good point with the surgeon model, where the author writes that, yes, I am saying that, whether it was 25 or 50% of the staff is devoted to documentation and or testing. It's like, well, like, we have a good number of ways to write better documentation, and we have ways of not needing to write as much documentation.
Yeah, there's definitely times when reading the book where I'm kind of like nodding along and agreeing with what he's saying, and then he'll use an anecdote that makes me realize, oh, I don't really get what he's saying. And now I realize that he's talking about, oh, we're documenting, we're making sure at the end of every day that we're checking in. I'm like, oh, this is great. We need more teams to do documenting. He's like, yes, and our book was 5 feet tall. And I'm like, oh no, this is something completely different than what I was imagining. A 5 foot deep book on paper. And they're like, yes, and we were so great. We were able to use typewriters, and that was amazing. I'm like, oh my God, like, this is just a completely different world. And I think I felt like I spent a lot of time translating the book in my mind, like reading it and going, okay, now let me recontextualize this advice 45 years later. Like, what does this mean today? And it is also really interesting, again, from that historical perspective of, like, this book is like pre-agile by like 20 something, 30 years almost, right? And like, I think it totally fits for the time. I think it totally makes sense. And I think it's interesting to view it through the lens of where we are now, and like, what did we leave behind on accident, or what did we not mean to, what are we relearning today is the thing I'm hoping not to find every time I read a chapter. I'm like, I really don't want to turn a page and find out, oh God, we're doing this thing that this book said, in 1975 not to do. And for the most part, we seem to be avoiding it, other than the things that the book says everyone always does, stuff like that.
Yeah, I think that's a really interesting way to pivot to talking about the namesake of this book, the chapter on adding people to a project that's already late, and how you do time estimation. And I think I'm wondering how many things rung true to people as still being an issue today, and what they were.
I think I want to correct that chapter in one sense, which is there's no such thing as adding there's no such thing as adding people to a project that's not late. Every project is late. The only question is how. I've, at least in my experience, I've never found a project that where everyone's like, oh, we're like way ahead of schedule, like we're cool. And if they said that, it was because they just didn't realize there was a lot of things that they didn't there were a lot of unknowns that are eventually going to come to bite them. So I think that there is only such a thing as adding people to a project that's late. But I also think that it's hard to completely apply it today, in that we don't have projects in the same way that there once was. I mean, some people really are working on projects. Let's say you're designing a smartwatch, and at a certain point you have to actually ship the device, and it's going to have whatever circuits it has. So especially in a hardware sense, and a software sense, especially if you're working on some kind of a SaaS platform or platform as a service. I mean, you're changing things all the time. You're rebuilding the plane in midair. So just the whole way we think about projects has changed. But that might be a little bit beyond the scope of the question, and I apologize for that. It is definitely true, though, that there's like Brooks's law is absolutely true in the short term, I would say. If you have a project that's already really late and you add more people to it, for sure at the beginning they're going to slow the whole thing down, because now on top of what everyone else was doing, now you have to also train new people. And I think that the way the book described it was more about adding layers of communication and the added cost that's going to have. That may be less true today because we've gotten better at communication, although we haven't avoided the problem entirely. And yes, there are problems with Slack, and there are problems with distributed teams, and there are problems with teams who are in an office, and there are problems with water coolers. There are problems with everything. There are problems with wikis, and there are problems with readmes, and there are problems with version control systems, distributed and otherwise. But at the end of the day, I think we have made significant gains in terms of streamlining our communication, and that has to some degree mitigated the effects of the law, but for sure not completely.
Yeah, I think it's a really it's a really interesting thing to think about, what we actually communicate without actively communicating right now. I think you were getting to some of this, Ariel, at the end of that list, where you were starting to move from things we think of as communication tools to things we think of more as like programming tools. But the ease with which I have of saying, oh, here's a set of changes, people review them, right? That's the integration of Git, integration with our CI system to make sure that, like, in general, it's going to be fine once, not only on its own, but once it's merged into master. GitHub or GitLab, whatever you're using to manage pull requests and to manage review. I mean, you look back at the stories of how NASA wrote its software in this era, and obviously some of that software had most of that software had a higher requirement for accuracy and not failing because lives were at risk rather than calculations. But they'd have books of pseudocode that were reviewed and approved before a single programmer touched a line of code. And that was something that they actively communicated, that they actively had meetings for. And we don't have any of that. So yeah, like, we still have communication problems, and adding more developers makes communication harder. But on the other hand, we've abstracted away, I think, some degree of the communication problems that would have been faced in the 60s.
Yeah, I definitely agree with that. I think some of the biggest changes are, like, we're not all writing in one giant assembler file, that has to all work together, and anyone can smash anyone else's memory and nuke the entire machine. Having, version control, like everything Amy said, like, our technological advances have allowed us to more readily add or remove people from a team without it needing this giant onboarding process. Like, I think, the book kind of talks about this, but we've thought about it already, which is like, we don't have to worry as much about the exact architecture of this chip we got custom made for our system, because we're just using the similarities. We are a few steps higher in the abstraction tree. Although I have to say, this book does come up a lot. My entire career has been consulting, and as a consultant, it is so common to be sitting on the other side of the table from a client, and we're chatting, and then they're like, I'd really like to get this done by the end of October. Like, that's not gonna happen. They're like, well, what if you just like put 18 people on it? You got them right. And I'm like, first of all, no, there's no way I could get 18 people on this project. Like, they're all going to be on top of each other. Just like, there's no way. And I have to like explain to them that exactly what this book goes over is like, adding more people does not equal more input in that way, as in like a lever they can just tweak whenever they want to get more output out. And you kind of explain to them the graph, and like, there's a huge dip, but eventually, yeah, if you scale up a team from 4 to 18, it'll produce a ton of stuff, probably more than you, the client, are ready to give them. But there's going to be like a complete standstill for the next couple of weeks while everyone's just trying to get their job done and figure out what's happening. So in some ways, this book almost feels like I want a Cliff Notes version to hand to all clients and managers, but I feel like it's already kind of done its job. Like, I feel like I personally hear less and less stories these days than I did like a decade ago of managers trying to pull this, trying to say, let's just throw 5 more people on this team and that'll fix the slowdown, which is a good thing, I think. I think our problems have shifted elsewhere.
Yeah. I think it makes me really fascinated to see some of the things that we as an industry seem to have either abstracted away or just accepted as things that are counterproductive to do. And then to see things that we haven't solved very well. I feel like onboarding fits into that. Like, there are ways to get the technical aspects of onboarding to probably be a little bit better. I don't necessarily have to walk and give somebody a tour of the mainframe room. But on the other hand, getting someone familiar with the code base, getting someone familiar with communication on a team, how a team works, how you get work done. I'm not sure that's gotten that much better, and I'm not sure we focus on it as much. I don't know. I mean, part of it is maybe we're onboarding fewer people at the jobs that I've been at than IBM in the 60s, when some executive says, and now we'll add 500 people to this project. But I do think it's something we haven't really figured out.
Yeah, that's definitely something I have thoughts on, TM, so I won't go into it too long. But yeah, I definitely think we, in current tech culture, kind of have like a real big focus on shipping and on getting something out the door and on value focus. And I think all that's important. But I do think that comes as a like unfortunate sum all to everything else. Like, it's so often where it's like, hey, well, I just finished this feature. Cool. Is it in production? Well, no, I'm going to do some documentation. No, get that thing up. And then that kind of culture cements into a tech industry or to a tech company. And, you hire someone a year down the road and it's like, oh, we have a thing on GitHub, clone it and figure out your machine. And then like they come back 3 days later, they don't know anything. They finally got the Rails app running and they go, cool. And they give them their first story. And then everyone, it's kind of that success hides problems mythos, where it's like, because the team's not falling apart because of onboarding, no one ever feels it's worth the time or money to invest in onboarding, and it's kind of sucks.
I will point out that the Agile Manifesto does say working code over comprehensive documentation. So it's definitely part of the way that our industry thinks. But I think it's also that when we talk about comprehensive documentation, that's not the same documentation that you're talking about. And I think that's a point of confusion for a lot of people. So the whole part of the idea of Agile is that you're working day to day with representatives of your users. And so you have this very, very quick feedback cycle, and ultimately the goal is create value for your users, right? So that part of that is making sure that they're able to use your product, but it also has to be a usable product first. And every bit of stuff that you layer on top of your code, whether it's tests, whether it's documentation, other stuff, it's all valuable, and it also is an added cost to change. So we're constantly balancing that value of flexibility against making sure that along the way people can can really access your stuff. And I don't think anyone would say that documentation is bad. Flexible documentation would be even better. And I do have some thoughts on that, but that's really not for right now. But there are some pretty cool, pretty neat tools out there that do offer a certain degree of flexible documentation. But ultimately, I think the kind of documentation that you're talking about is things like READMEs, project wikis. To some degree, there's the whole self-documenting code idea, floating in there somewhere. There's introspection tools that let you understand your system better. There's a lot of elements to the things that make it easier for somebody to either come into a project they've never touched before, or come into a project that they are on currently, but moving into another area of it that they haven't interacted with before, or they have interacted with it before, but not in the last few months, and it's changed drastically in the meantime. There's a lot of that kind of thinking that's missing right now, and I don't think that we have a good solution for it per se. But I think that much of the problem does come from this sense of, well, we don't value documentation because the Agile Manifesto says we don't. Well, A, that's not the same kind of documentation, and B, we do value documentation. We just don't value it as much as working software.
Yeah, I'd like to make sure we move on, but I think you're exactly on point there. But I wanted to make sure we get to the surgeon model and this idea of a very hierarchical world around one individual programmer, perhaps with it seems like the co-pilot is the pair who never gets to touch the keyboard almost. And then a surrounding cast of 8 other folk. And I was wondering what our reactions to this were. I think each of us has had maybe a different kind of gut reaction to it. And Ariel, if you could start us off with how this compares to the current typical setup. I think you had thoughts there.
Yeah. So I'm like, I don't generally encourage us in this group to go point by point through whatever book we're reading, just because I don't think that's necessarily a great use of everyone's time. I want to make sure that we go beyond just the reading in these conversations. But this is one case where I think a close reading, not a close reading per se, but at least really going through the points is a good way of thinking about how much of this is really relevant. So as Amy mentioned, we have the surgeon and the co-pilot, which are, I guess, like the 2 pairs who are, coding, and then, one of them is more active than the other. I think there's more of a sense of like mentor-mentee. There's always going to be a more senior person and more junior person, which does establish a certain uncomfortable degree of, power imbalance. But, that is what it is. But then we have like the administrator, which I guess is maybe like a manager. We have the editor, which is, I guess, a person. I mean, it just doesn't even seem relevant anymore. It's taking the code that the surgeon has written in the abstract, adding references, bibliographies, thinking about mechanics of production. Like that's stuff that you either is irrelevant or you have like code editor tools that do that. We have secretaries. I'm not sure what they used to do, but I don't think that we need them anymore. You have a program clerk, which is called Git today, or for some things it might be Subversion or one of the other version control managers out there. We have a toolsmith whose focus is on providing the tools, so that we have the entire open source community, which is really the toolsmith for all of us. As well as certain individuals who are like JetBrains or other companies who are focusing on creating text editors and editing tools, as well as things presumably like that weren't even thought about here, because what do you mean to deploy, right? That's not a thing. You just make a machine and then you deployment is I send the machine in the mail to somebody, or I put it on a truck. That's how deployment used to look. So I guess the Toolsmith would also include groups like, who is HashiCorp? That's what I'm thinking of, or Heroku, of course, or other tools, ops kind of groups, or again just coding tools kind of groups. We have the tester, who I think at this point we've sort of said that the computer is a tester, and you have to tell the computer, you have to also program the computer how to test. We have the language lawyer, which at least in Ruby is called Rubocop. I believe there are tools for other languages. You have JSLint for JavaScript. I mean, there's a little bit more than that. The language lawyer is also supposed to do stuff like suggest better ways within the language, more semantic ways in the language to work. So again, I think at this point that's basically called blog posts, Stack Overflow, and that one person on your team who constantly pull requests like, hey, you could do this in one line with this really neat method that you probably never heard of. So pretty much all of these are either outsourced, done by other people, or done by software. And to me, that's really interesting, because there's a couple of them that are, not relevant anymore, but most of them really do still exist. But we've found ways to avoid creating a whole surgical team and to still have those functions be filled in.
Yeah, I think it is definitely interesting to see how much of that has has dropped away, and alongside that, how much of the organization has dropped away. Right, this idea of the surgeon who, and this kind of flows into the next chapter, talking about the architect. Right, like the idea that you're going to have a design principle, or a systems design and a set of principles that go with it handed down to you as an engineer has kind of faded, I think, is, to use your words, back to you, Ariel, and I'll definitely let you respond. But I think it's interesting to see that as we build more and more complex systems, I almost wonder if we need some of that structure back, where we've lost the need for a lot of these tools, a lot of these additional, well, not people, they've been replaced with tools. And so the need for this structure has kind of dropped away. But then you end up with situations where you're trying to get, the 40 people who are working in one code base to come to a consensus about how they want to design something. And it's sheer chaos.
I have some, this is going to be pretty anecdotal, but my experience has actually been kind of the opposite of what Brooks suggests. But before that, I just kind of want to say that, he talks about a lot about architecture, the importance of the architect, the importance of having a unified system, that, beauty comes from unity more than, any individual nice feature. And it's not clear to me if that's about unity of design or unity of implementation, or both. And both of those, I think, have value. Unity of design definitely gives the user a sense of using a coherent product. I mean, if you ever use, like Apple products generally, there is an incredible amount of consistency that they make sure just sticks across the board. And Google does the same thing. Although probably to a little bit of a lesser degree, which may be why Google often feels like a bit of a more disjointed experience, because when you have so incredibly many, different platforms and tools and, hardware that you don't control and all that stuff, there's going to be some amount of chaos, but, it could also be a matter of how they're internally organized. I'm not really sure. I just certainly don't have any insight into Google, but anyway, that's one sort of frame of reference. I think in most companies, that's not handled by programmers anymore. That's considered to be a designer issue. So more like for UX people, thinking about the coherence of the design. And I think it actually works fine at this point. I don't think that you need one architect. You do need a team that works well together, that has good channels of communication. And there's also the value of like having the team feel empowered, feel sense of agency, which the author actually downplays explicitly. This is not just something that I'm bringing up like, oh, he never thought of this. No, he explicitly says, yes, it robs people their agency, and oh well. As someone who has looked at various teams and various people and how agency has impacted their work, I cannot in good faith accept that idea that that agency doesn't matter. I think agency is extremely important for people to do their best work, and for people to produce great products. So that's one area where I differed with the author. But then again, there's that other world of the internal consistency of the program. And in my experience, it doesn't matter how many architects there are. I've seen a case where there are many quote unquote architects, basically where there's a lot of freedom within the system to choose tools, but because everyone is really communicating well and on the same page, so everyone pretty much the code and the choices of how to implement something look very, very consistent across all multiple products, multiple microservices, stuff like that. And then I've seen another team where there was one person who was kind of handing down orders, and yes, all their products are in PHP, but I think they use about 8 different frameworks for less than that number of products somehow. And so it really depends more on the people, that and how much there's a sense of like, we want to jump to the next new technology versus we care about consistency. That's the thing that's going to determine that internal consistency a lot more than how many architects there are. So I read that chapter, I appreciated it, but I respectfully disagree, at least in today's context.
Yeah, this chapter was interesting. I started off like nodding along because it starts with talking about like the difference. Every programmer wants a small, sharp team. That's kind of like the thing he goes off on. He talks about like, you want a team of 10 good people versus a big swath of 200. And I can agree with that. Like, I love working with, small teams. That's what I've done like my entire career. And then, yeah, I got to the actual like roles and I was like, I had a very visceral reaction to the idea of the architect. And that's because not too long ago, like 3 years ago, I had a friend who worked at a nuclear power facility in Florida, and they had a lead architect. And he said what goes for everything. Didn't matter what you were writing or how small the system was. If it wasn't approved by the architect, it didn't go into the system. And I understand the need because of the safety concerns around a nuclear power plant and any software that deals with that. However, it was, again, like the lack of agency, it was crippling to anyone who worked there because he was also their boss. And I don't think that's a good thing to have the architect also be in charge, because he was very belittling to people. He was always power tripping about, no, my idea is the right way to build this. And he hadn't coded in 10 years, but he was the architect. So his way went. And that I immediately got flashbacks to all those stories I heard. I was like, oh, no. But then the more I looked at it and the more I tried to do the kind of translating to today, I came to a similar conclusion that you did, Ariel, about kind of like, oh, some of these have been replaced by tools. But then I kind of thought about it more, and I think actually some of these still very much exist. Like the tester is now like the QA team, which a lot of companies still have QA teams, and they do all that automated testing. And like the language lawyer is, like you said, that one person who really likes C on the team and is always complaining to you that you've allocated too much. And then like the toolsmith is just DevOps. Like we've replaced that. That's an entire industry now. Toolsmith has just become DevOps. And then like,
remember when DevOps wasn't people, by the way?
Yes.
It was just people. Mindset.
Yeah, exactly. And then like the administrator is like your project manager. And then like, I guess the architect is like you said, like a designer or like a project, I would think a product designer or a product manager is kind of how I think of things when I see them. And I thought that was kind of a novel way of approaching things. I like the idea of people having specialized roles. While I have worked almost exclusively in industries or in companies where everyone has the same role, like everyone's just developer and you just do your job, there is definitely a sense of ease and a sense of efficiency that comes from specialization. When people can be like, oh, I have this role, I am good at this. This is the thing people come to me for. And I think if that's the takeaway, I like that proposal. The idea of people should have a role and they should be allowed to be good at the one thing that they want to be good at, and that contributes to the team, versus this like amorphous mass where everyone's like, I'm also good at JavaScript, and then they go type a thing, I think can be daunting for someone to be like, okay, you're going to TDD all your tests, and you're going to self-document all these things, and you're going to make sure it all deploys correctly, and you're going to do all this. And while I think those responsibilities are normal to have, I think not having anyone who's good at one of those things can make everyone feel a little uneasy at times.
Yeah, I think there's an important balance to strike too with agency and control, because you can have all the agency in the world, but if you can't actually ship something or get anything done, then it's not worth it. And I think for me, a lot of the discussion of the architect really kind of rang true is the times I've been most productive in large code bases where, you know, and I'm roughly kind of defining that as like more than 5, maybe more than 10 people whose full-time job it is to do the same thing in the same code base. So not, well, I mean, I guess you can have JavaScript and you can have both your front end and the back end in the same code base, but in theory it would be, you know, more than 10 people on front end or more than 10 people on back end. You know, at some point, 10 people talking about hard issues, you're not going to come to a consensus. If you wait for it, it's debilitating because it's never going to come. And so in that sense, you know, I have felt an incredible degree of productivity and happiness in my job when in those large teams, there is someone who is, you know, obviously respected and talented, who finally says, you know what, like, this is my decision. Because otherwise you end up in a situation where you need to have groupthink in order to get anything done. And you can't, if you raise a point, if you have an idea, but you think that, oh, that's going to tick somebody else off, and you're trying to play all these politics to like get enough people to actually come to a decision, you can't actually raise anything that's going to be challenging, because then you know you're never going to get anything done. So you can't actually express what you want to. And you're just kind of spinning your wheels often. So in that sense, I really did like the idea of maybe a little bit more of a return to highly structured teams once you get to a certain size.
I think that's probably a theme on the whole. Like this, I mean, he was talking about how many people, how many hundreds of people, was it 1,000 people on this? I mean, you're talking about ridiculous numbers of people, like unfathomable numbers of people on a single team. And it is hard to manage that. And I think the biggest lesson that we've learned from the Mythical Man-Month and other books like that is just don't have teams that are that big. The smaller the team, the better. The fewer communication channels, the better. You know, don't try to solve a communication problem. Just don't have the problem in the first place. And it's sort of funny because you know, you're talking about having 10 people on front end, 10 people on back end. I've seen, like I've been on a team like that, and the one thing we could pretty much all agree on was that in retrospect that was the wrong way to divide people. And over time, the team actually did move in this direction of having empowered full stack teams where, yeah, there was, you know, maybe 2 people on the back end and 2 people on front end, and they were making all the decisions about a particular issue. So just reduce the surface area of a particular issue, and it turns out it's a lot easier to build consensus amongst 2 or 3 people. Whereas when you have everybody involved in all the issues, you're going to have a lot more debate. For some things that's necessary. If you're building, you know, if you're working for NASA on one of these like really, really high value projects where, yeah, you want to have that debate, so that's great. And in some sense there, I would say even more important to reach consensus because you're dealing with such sensitive and expensive stuff. But for most cases, for most applications, you know, consumer-facing things that we're writing, that's probably not as critical. And what's more important is that we make a decision, and we make a decision fast, and we try something, we see if it works. And in that case, having a very, very small empowered team will get you way further than having a very large, even more empowered team that has a lot more on its plate. I think that actually does relate a little bit maybe also back to, and you know, I don't want to take us backwards too much, but to the central proposition of the Mythical Man-Month, which is that, you know, I guess I'll rephrase it. People and months are not interchangeable. And sort of the way to address that, to whatever degree it can be addressed, is I actually think it's very similar to performance optimization. So performance optimization is not about being able to do things faster. It's about doing less things. And in the context of creating a product, I think it's also the same thing. It's about fail fast and move on to the next thing. And so the more you can have multiple, small groups trying different things at the same time, failing fast, and then focusing your energy on the right approaches, the faster anything is going to get done. So I think both from that perspective and from the perspective of just coordination, communication, creating a consensus and a common voice, like small teams are just, to me, very clearly the way to accomplish most of those things. And in those cases where you can't have a very small team, figure out how to make a small team. Like, I don't have any other advice, but there is probably just about always a way to make the team smaller and also empowered at the same time.
I think we'll move on now to language choice and thinking about how some of the productivity challenges that Brooks was facing in the 60s are maybe no longer in effect as we move more and more to higher level languages. I think Ariel pulled the money quote here. I can't quite remember where it was, but
yeah, I can read it for you. It's from page 94, the end of chapter 8. So I don't know what pages in other editions, but it's the end of chapter 8. Programming productivity may be increased as much as 5 times when a suitable high-level language is used. And there was a derivation for that number that wasn't just like pulled out of the hat. That was based on real data.
Yeah, I think it's funny to see a couple of these like key numbers that I think were coming out of this book earlier. I think we saw the origin of the 10x developer. And now I think we see some of the 2x, 5x, 10x, whatever you want to claim for higher level languages like Ruby and Python.
There's actually a neat study that I heard. I really wish I could tell you where it is, and I feel terrible that I can't. But there was like an episode of Ruby Rogues about the use of data to drive better, not just computer science, but also software engineering, and how those are different things. But that there is data out there. Apparently, there was this massive study by Microsoft where they looked at like all their projects and tried to figure out what they could correlate with less bugs, basically. And they looked at a whole slew of variables, and it turned out that there was exactly one variable that they could find a clear correlation for. And that variable, surprisingly enough, was lines of code. Nothing else mattered. Literally, just the less code you write, the less bugs you'll have. And based on that, it sounds like the best thing that you can do for the sake of reducing the number of bugs is write in a very, very terse language. A language that lets you get the most running, I guess, executing program for lines of code that you write. So that made me feel pretty good working in a language that I have friends who like make fun of me, like, oh, your program or your programming language looks like pseudocode, like it's so it's so dense. And I'm like, no, that's the point. That's how we avoid having so many bugs, because there's just less code to have bugs in it. So it's not just programming productivity in the upfront sense of it's easier to just bang out all those lines of code and to understand it as you're going. It's also just easier to write the right code the first time.
I was just going to say, this is where Yagni comes up as well, where if you ever have a decision between writing something you're not sure you need or not writing it, the answer is always to not write it, because any line of code is a line of code you have to maintain forever, and it's most likely to get bugs in it. So not writing code is always better than writing code, which is a fun thing to tell clients. They always look a little confused that the programmer's telling them that. But I always assure them it's better to not do this. than it is to do this and then regret having written all these extra lines of code.
Yeah, I think it is a really interesting point when you hear about a lot of the war stories from the 60s, just hilarious things that are, you know, really odd bugs when it comes to certain quirks of certain hardware and particular libraries or drivers. And now, you know, I think my worst bug war story is something about the JRuby PostgreSQL adapter, which in all honesty, I mean, it's just a library for generating SQL. Like, it's not that bad. And I think it's really true that like a lot of our problems have been, a lot of the problems that might have been formative for people writing code and people managing people writing code when this book was written, they're just no longer things that you know, really come to be defining experiences for the vast majority of programmers. Like, absolutely for some of the lower lying libraries, absolutely, but the vast majority of us are never going to run into this.
Yeah, I'm pretty happy that like I once in my life had to deal with this with a seg fault, and that's it. Like, I can't imagine what it must be like to have those kinds of really low level errors all the time before you can even pass go. It's just terrifying to me. Which is why I think actually, Rust, for example, is starting to become a lot more popular. It's that promise of, if you can't use a suitable high-level language, then use a suitable low-level language. Avoid having to manage things that we can figure out how to manage for you, and you can really just focus on what's important, and avoid all that noise and thereby extra development time and extra debugging time that all that management is going to create, because it's just generally not worth it. And I think it might have been worth it once upon a time, when 26 bytes was 1/300th of your memory space, and there was, I guess, there probably was no hard disk to speak of, but times have changed, and it's amazing how long it's taken our industry to realize that.
Yeah. I think we're coming up on the end of our time. So I want to make sure that anyone had the ability to share some closing thoughts. I know one thing that we were all interested in talking about was the second system phenomenon. So I think my closing thought will be just how much I wish that all programmers came with like an instruction manual, a little bit of a history book that says, oh, I battled this particular bug, or, my biggest project got burned by, performance issues with Ruby. Therefore, never ever try to convince me that Ruby can be performant. And I saw a decent amount of that in the second system thing, where eventually maybe we can overcome some of those formative experiences, but you develop some really strong preferences earlier on in your career, and especially if you think about the first system back then would have been a 5-year project possibly. So knowing what minefield someone has stepped into is really a good predictor of seeing what they want to avoid at all costs.
Yeah, we haven't finished the whole book, but my clothing thoughts for the first half of the book are, I'm interested to see where it goes from here, because I feel like this is the most kind of tepid we've been about a book so far, and maybe it's because it's the oldest book we've read so far as well. I think there might be a correlation there, but as far as the second system effect, just to put my thoughts in there, it just strikes me so much of, not intermediate developers. Like, there's always been this saying, and maybe this because I deal with juniors a lot, is like, the most dangerous developer is the intermediate one, not the junior, because the junior will normally be scared and ask a question. But the intermediate developer is like, I got this. I've done this before. And then they just go build something that you're like, oh my God. Like in Ruby in particular, intermediate developers love metaprogramming, and they will metaprogram everything because they understand it. And then everyone else has to come back and clean up the mess later. And I also feel like there's a weird adage where like second system effect could be your entire life, kind of like what Amy was talking about. Like you could be so burned or so just molded by your first project that forever on, you're on your second project. You're always just thinking about ways to adjust from the last one. And it really takes that growth from the third to the fourth to the fifth, where then you can oversee like, oh, this is what it looks like to build projects, plural, and you can start to see the real ebb and flow. I can see that myself now looking back to like the way I built projects 2 years ago were actually just responses to projects I built 4 years ago. And now it's like I've reached a level of like, oh, no, this is how I write projects because of me and because what's best for the project, not because of a response to the way I used to do things because of someone else's response, you know? And it's interesting to get that clarity.
I don't know if you saw, I was laughing pretty hard because I have totally been that intermediate developer. and I continue to be that intermediate developer. And I probably will always be that intermediate developer who, you know, tries to be too clever for his own good. So, you know, not like the, you know, Amy's kind of burnt by experience developer forever, burnt forever by experience developer, but more the, you know, forever the developer who like is like, oh, I learned this thing and now I know everything and now I know how to do it and it's going to be great. the eternal optimists. But I do want to actually throw up one quote. Like I said, I mentioned at the beginning that there were some things that were more timeless and some things that were more, you know, they kind of had a pretty clear expiration date in the book. There's one thing really right from the beginning of the book, but there's like a chapter towards the end of the new edition that just gives like bullet point summaries of the whole book. So this is just pulled out of that summary, but it's the same thing in chapter 1. A programming systems product takes about 9 times as much effort as the component programs written separately for private use. And what that basically means is that like that hacky thing that you threw together in a weekend is going to take you forever to turn into an actually useful system for real people, because there are so many little details and things that you're going to have to worry about. And that takes me back to like, you know, when for example, when Rails was first came out and DHH released that video that everyone, you know, was talking about, like, you know, oh, look at all the things that I didn't do, and everyone was like, okay, we're just going to like write Rails apps, and we're going to have, you know, we just have to have like a little business model, and then, you know, in about 10 minutes we're going to have our app. We can already, you know, start going live, and of course it wasn't like that. And I think it was really summed up really nicely by Avdi Grimm, who once wrote about how he is not all that excited by functional programming, because even though it's a really cool idea, most of what you do in real life programs is cleaning up horrible data, you know, fixing up strings, all kinds of like really little detail oriented kind of, you know, yucky stuff. And there is no language in the world. There's no functional programming. Functional programming certainly can't save you from any of that, because at the end of the day, it's just dealing with really gross, you know, really messy reality, and reality has always been messy and always will be messy. So to me, I think that's where the other 8 parts out of the 9 times come from. It's just dealing with the messiness that is reality. And I think it's just interesting that, you know, in this book, you already see the point of just because you have an idea doesn't mean that you can execute it effortlessly. There's always going to be that 1% inspiration, 99% perspiration that Edison supposedly, according to that quote, mentioned. Like, we are always going to be dealing with details, and we may as well embrace that, you know, the world is messy, and if we want to solve real problems, we just have to get our hands dirty. And we have to be ready to deal with all that messiness, and that's not something that we should be frustrated by, or at the very least, I don't like to say should anymore. I've been trying to train myself on that since NVC. We don't have to be frustrated by it. We can embrace that, and we can enjoy it, because that's the thing that tells us you know, that's the bridge between like a really cool, neat idea in theory and an idea actually being out there in reality, helping people, making a difference. So that was my takeaway from the first almost half of the book.
Yeah, we are almost halfway. I suspect we may end up doing just the next third. I don't know. I don't think we've discussed yet how far we're going for next time. But thank you again, everyone, for joining us today. And you can stay updated with our events for this Dev Empathy Book Club by following us on Twitter at Dev Empathy. And of course, don't forget to join us on Slack. There's a link you can follow on our site, devempathybook.club, to join our Slack. And we look forward to interacting with you and growing as a community and becoming better developers and better people. So thank you, everyone, and we'll see you next time.
See you.
See ya.